What if I told you that the price of the electricity that's powering your screen right now is one of the hardest things in the world to predict? Seriously. So today, we're going to explore exactly why that is and how a new breakthrough in forecasting could actually be the key to unlocking our clean energy future.
Right, so the price of electricity, it's not like the price of a gallon of milk that stays the same for weeks. Nope, it is one of the most volatile commodities on Earth. Prices can absolutely skyrocket or just plummet in a matter of minutes, all based on something as simple as a sudden change in the weather.
Well, because getting this right is about so much more than just money. An accurate forecast is the absolute foundation of a stable, reliable, and, most importantly, a green energy grid. It's what allows us to confidently switch over to renewables without having to worry about the lights going out. Okay, let's start by digging into the challenge that forecasters are really up against here. This isn't just a simple numbers game, It's more like a dynamic puzzle where the pieces are constantly shifting. Think about it. Renewables like wind and solar have almost zero marginal cost. That just means, once they're built, it costs basically nothing to produce one more bit of energy. So this can flood the market with cheap power, sometimes even pushing prices into the negative. But when the sun isn't shining and the wind isn't blowing, we still have to rely on expensive fossil fuels, and that causes these massive price spikes. It creates this weird split market, pulled apart into two extremes, super low and super high prices.
So who actually cares about these forecasts? Well, pretty much everyone. From the folks running the power plants to the engineers trying to balance the entire grid, a good forecast is their crystal ball. It lets them schedule the cheapest, cleanest power, it helps them prevent blackouts, and it lets them avoid firing up those really expensive polluting backup generators.
All right, let's talk about the two traditional ways people have tried to tackle this problem and see how they kind of fall short. For years, forecasters have been forced to pick between two pretty imperfect options.
So on one hand, you've got these data-driven machine learning models. They are fantastic at spotting patterns and spitting out an accurate number, but it's a black box. It's like a magic trick. You see the amazing result, but you have absolutely no idea how it was done. Then on the other hand, you have fundamental models that try to simulate the entire market. They show their work, which is great, but they're often way too slow and clunky to keep up with the real world's crazy price swings. And what's so cool about this slide is how it visualizes that gap right in the middle. You've got the accuracy of data-driven models over here, the transparency of fundamental models over there, and this big, empty space in between. It's a space just begging for a new kind of model that's both accurate and understandable. Okay, so before we can really get the solution, we need to understand one core concept. It's the idea that underpins the entire electricity market, and it's called the merit order. Think of it like this. To meet the country's electricity demand for any given hour, the grid operator calls on power plants one by one. They start with the absolute cheapest ones to run, solar and wind, and then they work their way up the ladder to the most expensive. And it's a very methodical process. First, you figure out the marginal cost for every single power source. That's just the cost to produce one more unit of energy. Then you see how much power is actually available from each of those sources. And finally, you stack them all up from cheapest to most expensive, and that creates a supply curve for that specific moment in time. And here it is, the final crucial step. This is the real kicker. The price isn't the average cost of all the plants running. No way! The market price is set by the cost of that very last, most expensive power plant that was needed to satisfy demand. That single plant sets the price for everybody. So now that we get how the merit order works, let's look at the breakthrough, the thing that combines this fundamental logic with the power of modern data science. This is the key question the researchers started asking. What if you didn't have to choose between a transparent model and an accurate one? What if you could have both? And here is the brilliant answer, the data-driven merit order. It takes that clear, logical structure of the merit order, but instead of relying on old, static assumptions about how efficient a power plant is, it uses machine learning to learn the real-world parameters directly from the market data. It basically stops guessing and starts learning what's actually happening out there. And the proof is right here on this chart. That black line? That's the actual real-world price. See those other colored lines? Those are the old models, and you can see how they miss the big swings. But look at the red line. That's the new hybrid model. See how it just hugs the true price? It perfectly captures those sharp peaks and those deep valleys. That is the breakthrough. So the model's way more accurate, which is fantastic, but honestly, the real magic is what it tells us about the inner workings of the market itself. And the numbers just don't lie.
This chart shows the mean absolute error, which is basically a score for how wrong a forecast is. So lower is better. And the new data-driven model, right there at the bottom, gets the lowest score. It's about 10% more accurate than even the best black box machine learning model out there.
But like I said, a lower error score is only half the story. Unlike one of those black box machine learning models, this new hybrid approach lets us pop the hood open and see why the price is what it is.
And this is just fantastic. Because the model understands the why, it can tell us exactly which type of power plant, the marginal technology, is setting the price for everyone else at any given time. We can finally see hour by hour whether it's a gas plant, a coal plant, or even power being imported that's driving the market. This transparency isn't just for academics. It reveals huge economic stories. For instance, during the 2021 energy crisis, natural gas prices went through the roof. This model clearly shows the market reacting in real time, switching to other fuels to keep costs down. It's not just predicting a price, it's telling the economic story behind that price.
So, what does this all mean? Well, it means the smarter, more transparent forecast is an absolute game changer. Policymakers can design better markets, grid operators can keep the lights on more reliably, and investors, they can more confidently fund the renewable energy projects that are going to power our future.
And it leaves us with a really powerful final thought. Maybe the future of AI isn't just about finding patterns in data. Maybe it's about teaching our models the fundamental economic principles that govern the world. And perhaps that is the real key to building a cleaner, smarter energy system for all of us.